Hello everyone. Today I would like to introduce the subject of metrics, and I'd like to start with the lines of code. I'm introducing this subject because I think it's really important to understand metrics and to understand how to use a metric. For instance, metrics, it's one of the three pillars used in observability. As you know, you have logs, trace, and metrics. But just having numbers or nice charts, it's not enough. We should understand what to do with them, how to read them, and maybe combine multiple metrics to gain some knowledge and wisdom about our systems. And you can see that why is this really important. For instance, when you go to the doctor, it takes metrics from you. It takes your heartbeat, it takes your blood pressure, and things like that to make sure that you are behaving normally. That's it. That's what he expects, and you expect also. And the same applies for architectures and systems that you have deployed. Today I will introduce a simple one, which is lines of code. And most people think that lines of code it's only about the number of lines. And at first you can always say, okay, the only thing that I can infer from the metric lines of code is if the project is big or not. Maybe I can ask you at this time before going into details. What about if you start to understand how many lines exist in files or models or package or classes? Maybe start to say, okay, maybe I have big classes. So if I have big classes, maybe I have to refactor them. So now you understand why a simple metric that just counts the rows can give you information and other information also. Imagine that you count the lines and you can understand how many lines are comments and how many lines are not comments. And then if you have, for instance, 1/3 of the lines or 1/5 of the lines are comments, maybe you can infer something like, maybe my code is well documented. Of course, maybe you need peer reviews to make sure that the documentation written, it's good documentation and not just names of methods and parameters that are usually generated by automated tools. But what I'm trying to tell you is that don't try in advance to say, okay, from the name of the metric, I can infer its purpose. It's more than that, and I will prove you here that the metric lines of code can be applied to a lot of different areas, not only technical. So this is our agenda. What are lines of code? It's intuitively probably already know how to interpret estimation formulas that you can use. I will give you 10 metrics, different metrics where you can apply the lines of code and can be helpful for you or your manager or even DevOps, for instance. Recommended line of code ranges. What are the best practices? Say about what are the right number of lines, for instance. And I want to be sure that you understand that, okay, usually the approach that I'm using here applies to language like Java, Kotlin, maybe Python, let's say the mainstream language. Of course, there are other languages where you probably develop in a different way, or maybe the code is highly generated by tools and things like that. Maybe you have to adapt the rationale that I will explain here to those language. Don't take this as granted as 100 scientific proof. It's not that intention. Is just to give you the mindset, the way that you should look into a metric and try to gain some wisdom and understanding about that metric and to apply it in your current context. Don't take it as a final proof or a final truth, to be more precise, about the metric. And if you are a senior or your intention is to be a senior software engineering, you start to understand there is no let's say hard truths. It's just everything. It's about a trade-off. You have something and you say, okay, this is a good solution. It's not the best solution or the right solution. It's the best in this context, and the same applies to all of these things. Okay, there are some metrics sometimes that, okay, they push you to a definitive conclusion. Imagine that you have 0 logins in a metric in a system. You say, maybe there is a problem with a login in my system. That it's quite clear. But sometimes you say, okay, usually I have 200 logins and now I'm having just 10 or 20. Maybe my system is a problem. Or maybe it's holidays and probably even the 10 or 20s are quite surprised to be there. So depends on the context. Don't take it for granted. The numbers, but take the explanation and the rationale and the mindset about it as serious. Okay, so let's start and go into details. So what is lines of code? It's the total number of lines in a code base, includes code, comments, and blank lines. And for instance, if you use tools like SonarQube and and similar, they sometimes they split this. They have the lines of code, they have the number of comments, the blank lines, and then sometimes they even distinguish between lines of code and statements, because sometimes they are different. Because for instance, in Java, you can put multiple statements on the same line if you use a semicolon, and sometimes people forget this. Okay, and it's used to access project size and complexity. Why is line of code important? First, the code size is quite intuitive. The reason, complexity, larger code base may indicate higher complexity. That's a great, there is a high relation, of course, between these two concepts. And efficiency, comparing lines of code over time can indicate productivity or inefficiency. For instance, sometimes you are, let's say, developing new features, incrementing features, but you don't see the incrementing on the number of lines. Maybe it's related with the people. Are they really developing and implementing something? Maybe they are all starting on the database and configuration. They are not doing, let's say, a kind of agile approach where you try to integrate everything. Just an example, but I will go into more detail in a moment. And technical debt, large and fast growing line of codes could mean feature debt, meaning that if you have a lot of lines and when you cross with other metrics, you start to understand, okay, maybe I will have technical debt. Imagine that the number of lines increase, but for instance, the number of tests doesn't increase. Well, you can always say, okay, but we have another metric for that. It's called coverage. Yeah, that's right. But even the coverage is highly related to the number of lines. What information can we get from lines of code? Project size, of course, maintenance needs, bigger project, more maintenance. And there are a lot of things that I will talk, not here on this slide. Bug tracking, correlation between line of codes and defect rates. Because imagine that you can create a formula that says, usually you start to measure your project, the growth of your project during development, and you start to find an average that you say, every 1,000 lines, I have 5 or 6 bugs. So if you need more 3 or 4 months of development and you developed in a, let's say, linear way, it's not linear, we know, but imagine that it's a linear way when you can predict how many bugs are expected. And if you cross that and ask to the quality team how much time they take to fix a bug, or even the developers, you start to understand how much buffer of time your project will need to fix the bugs before the project is completed. Again, it's not a very precise science, but you can establish at least some confidence. Let's say you can trust the system, let's say 80% or something, which is quite good. It's better than have nothing, just guessing. Okay. Churn monitoring, say high-churn line of code files may be unstable. High-churn meaning that modified lines or modified files. It's a concept that sometimes it's used, this word. And review prioritization, focus code review on large or fast-growing files. If you are measuring the growth of the number of the lines, and if you split by file or package or something like that, you start to see on a chart which files are growing fast, and those are the ones that probably want to focus your code reviews and make sure that they continue on their quality, or you want to improve or make sure they are compliant with the quality standards that you have in your company. So some useful ratios regarding lines of code. Comment density. You have the number of lines for comments, for instance, and you divide by the total. So you have a percentage, for instance, of how comment is your code. And usually between 15% and 25% is quite good enough if the documentation is good. Because some people say, okay, more documentation, better. But there is a sentence that I heard a long time ago, when someone said that if you add too much documentation, imagine that you have 50% documentation, you can enter in, let's say, in a philosophical debate. If you are developing code with comments or comments with code, that's it's a little bit fun, but there is some true in this. So usually this documentation should be enough. Other type of documentation, you want to be in different files. You comment your code, you don't comment the features. The features, you have something called requirements and functional specification, things like that, where that should be explained. Maybe you can put some address if it's standardized in your company. Code to test ratio, it's the same concept, the number of lines of code that you have divided by the code that you have. Usually ideal is 1:1, that will be the ideal. It doesn't mean that's the true that you have, 2:1 to 2. Meaning that, okay, you should try to have less tests code than the code. Otherwise, probably you have high coupling, but sometimes it's not easy, depends on the code. but for one side, because usually if you do unit tests or something like that, usually you have more code on the tests than on the code. It's take this ratio, let's say, with a grain of salt. Okay, defect density, number of defects by, for instance, 1,000 lines of code. Why 1,000? It is as good as any other metric. For instance, for Java projects or a similar language, this number is quite good. But for instance, if you use functional language, Python language or something like that, where you write less code, maybe you want to reduce this line, because the increments of code that you do on a weekly basis or sprint basis, you don't add too many lines, just a set of them, and try to find, okay, between releases when they go to test, so I can test for defects, how many lines usually my project grows, let's say 200 or 300. So make that as your base. It's not at 1,000, it's a magic number, but usually it's easy to remember. So, but of course we want, when you divide this, to have less than one bug. But okay, maybe if you are working with legacy code with a lot of bugs, maybe for a while you want this probably less than 5 or something like that. You are refactoring code and things, and then you change to another value. It's the same concept that you use in quality about quality gates. If you have already a project, you want to force the tests to be 70%, you don't want to start with that metric. You want to start probably with 20 and 70 for new code. So you make sure that all the code migrate to 20, then we grow to 40%, for instance, then later you move to 70. Otherwise, it will be a risk. You're receiving alerts say it's failing, because it's impossible in a fast way to make sure that it's compliant with all the quality that is expected. And you can apply the same for refactor. You can put here the lines of code per file, and you have the average number of lines of a class. Okay, and then you understand what will be the need to refactor or not the code. Okay, churn rate, again, the changing lines or changing rows, for instance. The number of changing rows divided by all the rows over time, low is better, because if it is a division, if it's not low, if this number starts to grow a lot, it means that the number will be higher. Okay, if the total number of lines grows but this doesn't change, this value will start to be low. It means that you don't have to change the code. But if, for instance, you are introducing features, updating features, and the change is not being changed, okay, maybe it's time to look into the code. Maybe someone is duplicating the code. So there is always some things that you can get from these numbers. But what I'm trying to say is that only with the lines of code and other metrics that you probably already have in your company, you can take a lot of information in different areas: quality, the size of the project, defects, what's happening with the team, what's happening with the growth of the projects, and things like that. So use this to monitor code health, maintainability, and coverage. But there are more than this that I want to talk, and we will see some use cases. So let's see some quick examples. Let's say code bloat. A rapid increase in lines of code without new functionality could sign code bloat. I think it's quite intuitive to understand this. So the number of lines is growing, but I'm not introducing nothing new on the system. Maybe I should check what's happening. Maybe someone is having audit and logging and things like that. Check if it was planned or someone is refactoring the code to have more information, and if it's following good practice. Because sometimes you are adding code, but there are frameworks that, rather than for you to mix the log, for instance, in the middle of the code, maybe you have expected-oriented programming and other ways to inject code at runtime that can help you. So the code per se doesn't grow too much, but you have the new, let's say, no functionality in your application. So high defect density, meaning many defects. High line of codes could lead to more defects. That's quite intuitive. That's how they appear. It's when we write code, right? Use defect prediction based on lines of code to foresee possible issues. So if you start to imagine that you are in Excel and you count the number of rows every week, and then you ask for the quality team to give you the number of defects, and you start to see if there is a linear or a log trend line, and this allows you to guess what do you expect in the future. Because the code, it's the same application, same project, the same persons usually, and okay, so they behave the same. Maybe the bugs will be related. Of course, it's not a line. Sometimes there are ups and downs, but that's the reason that we try to create a trend line, not let's say a fitness, as they say, machine learning line. So if you have you cannot predict that tomorrow you'll have 7 bugs. Maybe you have 10. Maybe other day you have 5, then 6, then 9. But you have a kind of an average to say, usually I have 7 every week. And that's the approach that you should have. Development time, another, if you, it's the same concept as the fact. You have, you can guess how much time it takes. If you understand that a project like this takes 4,000 lines or 5,000 lines, you have comparison. If you talk with project managers, they have great, usually templates and tricks like this to help them to guess the time for projects, because they were in previous projects and they say, okay, this kind of features with login, managing tables, because if you look, if you are developing a back office, sometimes it's a different project, but if you look more deeply into it, they are quite the same. You have tables with search, you have places to enter information, update, delete, search, and things like that. Most of the time, maybe 70%, it's like that. So somehow, by the increase of lines of code, and you can guess how much time it will take the project, because you can guess somehow what will be the range of the size of this project. You cannot say that is 6,000, but maybe you can say between 5 and 7. So you have a range, and with this range you can even have another range to say the project will take between 4 and 6 months. And that's better than have nothing, right? So neglected files, very low churn, very high lines of code potential, and maintained file. If the lines of code is growing and there are not changing files, maybe there are files that are being neglected. It doesn't mean that it's true, but sometimes these metrics gives you tips for you to look for. You say, okay, I don't know if that's true, but let me check. Okay, what's happening here? Okay, maybe it's a false alarm. Great. Maybe it's not. Okay, I should do something about it. So how to read lines of code? This is just usually this kind of charts that we see when we are using lines of code. For instance, you can have weeks, you can have lines of code, and lines of code per developer, useful for retrospectives and work balancing. So you can check the progress based on lines of code. I know that it's debatable, and I have this discussion when I was at a college, that sometimes lines of code, it's not a good metric for this. But again, it's one of its uses, okay? And when you don't have nothing, it's a starting point. Maybe there are other metrics that you can combine and help you to complement the lines of code to make you create better guesses about the future, okay? Let's see some use cases. Let's see an estimation formula, some scenarios that you can apply so you can have a kind of a mindset and create your own scenarios. So let's say we want to estimate the development time. So the time will be the lines of code divided by the productivity rate, meaning first we have to establish what is this productivity rate. So where lines of code, of course, it's line of code for the feature or project, and the productivity rate can be something like average lines of a code developer can write per hour. It's not that you will count in 1 hour what the developer is doing. Maybe you take a full sprint and say this developer introduced 300 lines of code. And now you divide, for instance, if it's 40 weeks or 35 weeks per week, you have probably 80 hours. You divide and you say, okay, this guy develops 5 lines per hour. And now you have a productivity rate. And you have the number of lines, so you understand how much time it takes on hours to develop the complete feature. If you think the feature takes, for instance, 1,000 lines of codes, you have, of course, sometimes you need history for this. Sometimes you have some guessing. Maybe sometimes you need help from the project managers. But again, it's better than nothing. It's something to look for. It's tools that you can use to think about what you have. Okay, and sometimes it's quite important. I remember that in most of the meetings that I go, sometimes as an architect, you have to sometimes provide numbers. And even if they are not very realistic, maybe you can trust them, let's say, with a confidence about 70%, 80%. But a manager or to take decisions, it's better to have these values than to not have nothing. That's it. Otherwise, it's just an opinion. But when you create numbers and you have formulas, people trust on that. Say, okay, this is real. this developer, or on average, one developer of this team develops this number of lines. We expect 5,000 lines because in previous projects I work on, it was around this, or it was around between 4 and 6,000, and I expect this time to develop this. Okay, so we have here and apply to apply this. Let's say you have 2,000 divided by 15 lines per hour. So you need this hour. So now we understand that you'll need at almost 1 month of one developer to develop this feature, and it is as good as any other. It's better than nothing. A second formula that you can use, there are a lot of them that you can create. I'm just putting some of them that sometimes they are used. Maintenance cost, how much it costs to maintain the code. So we have the cost, you have lines of code, plus the defect density and how much it costs per defect. It's quite intuitive, this formula. So you can say defect density, it's average defects for 1,000 lines of code, and how much it costs to fix on average a defect. Let's say it's this number, 800. So if you do the math, you can say, okay, for these lines of code that I want to fix, it's a project with 10,000. In this case, it was just less. I'm trying to guess how much it costs to, for this one, for 50 lines of code, let's say it's 50,000. This one here. It will take me 24,000 euros, dollars, or whatever the money is. Okay, that's a formula that you can use to guess, not to guess, but to estimate how much can you spend on fixing your project. And this is really useful because in the past there was one specific project that I was hired just to fix bugs. It was bugs that were in a bank application, and they need seniors to do that, and they hired me to that. I'm not a specialist. It's not that I like to troubleshoot, but I have a kind of let's say skill to troubleshoot things and find quite easily bugs and a range of ways to find them. And they hired me, and okay, probably someone did this type of cost, how much it costs. To the cost per defect will be the hours they expect for me I take to fix the defect, plus the price, my rate by hour, and you can use that to say how much does it cost to fix all these things, how many people do I have, and you can have a budget for the fixing your application. Now the defect prediction here, so predicted defects lines of code, again divided by 1,000, can be a different number, multiplied by the historical defect rates. It's the same concept. So the defect rate observed per 1,000 lines of code in the past for similar projects. That's the way to see this. So I have a project with 100,000 lines with 5 defects per 1,000 lines. So I expect to have 500 defects. And usually this is not as strange than you may think. I remember that sometimes some big companies, they say, we expect our application to have, let's say, 2,000 bugs. It doesn't mean that they know that they have those bugs. They do this kind of formulas to guess. And then they expect to start to fix bugs, and this number should start to decrease, and based of course on the historical, because they start to understand, okay, then it's not anymore 5 defects for 1,000, but now I'm having 3. So this number will start to reduce, and they have a kind of a line converging to 0. It will never be 0 unless your application is really small, but for big projects it will never be 0. But as someone once said, a bug, it's only a bug if it's perceived by the end customer. So take that into consideration. And another form is, for instance, refactoring pressure. This is quite more complicated, but I think we can understand how it works. So you have a refactor index. Let's say the lines of code per file. You have a file, and let's say you have, for instance, 1,200 lines of code. And now you have the number of lines on an average class. That's the number of lines. And you want to multiply with the complexity score. And this formula will give you let's say, the importance that you should take into this specific class or file that you are analyzing to understand if it needs or not refactor. It's not that the number will say to you that should need a refactor, but if you do this to a set of files, the files with the bigger number, you should look into them and check, do they need refactor or not? Okay, that's what this formula is giving you. So we have an example here. We have a file with 1200 lines of code. On average, a class has 300 in your project. So if you have a file here, it says that this file has 4 times the number as an average class, because sometimes there is a high relation between a class and the file. And imagine that you have a complexity score. You can get this complexity score as you may wish, but usually we have tools that can give you, for instance, the cyclomatic complexity or other metrics that can show how complex is the code. And usually complex code, there are a lot of metrics, and I will address them in future videos. But usually you can go with cyclomatic complexity. If you don't understand what is cyclomatic complexity, imagine that you look into the code and there has a lot of conditions like if, whiles, and fors, because all of them need conditions. So if you see a condition, if condition inside an if condition, you start to guess if you try to do tests how complex this is, because there is true or false on the first if, and then the if nested on the other if will have 2 more results. So you have at least 3 paths here that you can follow. So if you have 3 paths, okay, you need 3 tests, so the complexity will be 3. So you can see how complex a code can be if it has a lot of conditions. So, and usually these are the codes that should be refactored. That's why it's a good metric, this one. So I put here, if you want to pause or copy paste this or check, I put here 10 formulas. There are others where the line of codes have high importance, like estimated at time. Some of them we already saw in the other slides. Maintenance cost, fat prediction, refactor, common density, already saw all these formulas, but I put it here as a kind of a table that you can use. Code to test ratio, defect density, churn rate, code growth rate, and productivity measure. In the directly and indirectly, we talk all about them. This one is about the change in the code. But if you look into them, and I invite you to do, look into them, try to understand and get some wisdom from them. Because sometimes things are just a number, but we should start to, if it's not already the case, to read the formula like you read your language. Okay, you look into the formula, say, this is the division. What does it mean if this number grows or this number decreases? And what happens when this productivity rate increases or grows? Sometimes it's good for you to put in an Excel and ask to put a chart so you understand better how it works. And when you gain this information, and if you are a leader or someone on craftsmanship, quality, and things like that, or you're just a developer that want to understand this, or maybe an architect that is taking, let's say, refactoring a big project or changing a project that exists, or you are managing a project that exists, knowing some of these formulas will be great. And if you can even build your own formulas based on these ones or others, better. That's why I'm introducing first the lines of code, because I think it's the simple one to understand. It's just lines, but you can see what these lines can say and expose about your project in different areas. Not only for the developer, not only for time, not only for maintainability, not only for quality, and so on. So recommended values, okay, take this, let's say 50-50, but usually small projects, they have 2,000 lines of code, at medium projects 10,000, large projects 50,000. Of course, this is just for regular projects. I once worked in a bank, our project had 1 million lines. So it was a legacy, it was a project we were refactoring and split in 30, around 30 models, so it will be, probably it will match large projects. This one, maybe our ones were just gigantic. But if you are in a company where most of the projects have more than, let's say, 100,000 lines, maybe you want to reschedule the way you see this. Maybe in your company, a small project is something that starts with 20,000 and the medium is 100,000, and the other ones is let's say multiply this by 10 or something, and maybe it fits your scale. So it's on you to create the right scale for later apply the formulas. But the formulas about to grow 1,000 lines of code still remain, because if you have people developing, people are people. It doesn't matter if the project needs 1 billion or 100 lines of code. It's just the same person and works in a specific rate that you want to understand in your formulas. Okay, by object or item time, a class size, usually these numbers, they are somehow quite right from my experience. Class size between 200 and 300 is ideal for maintainability. If a class contains more than these lines, maybe you should refactor your code and split in different classes. And there is always ways to refactor and make them plain. Probably you have to rename the class if it's possible or not, of course. But usually this is a good approach. Method size, no more than 20 to 50. I agree with this value. I once worked as, let's say, 50% of my time as a craftsmanship, on the craftsmanship in projects. And I always say to the people, if you are developing a method, I should see all the rules of your method in a monitor. Of course, you have a 4K monitor, or you, let's say, change the layout of the monitor from landscape to portrait. You can have more lines, and it was a joke, an inside joke on the company. But usually between 20 and 50, I think it's a good measure for a method. And there are some script files. There are other metrics that I can say to you regarding lines of code. There is a rule, I think it's 30, 30, 30. Everything should be 30. So a method shouldn't be more with 30 lines. A class shouldn't have more than 30 methods and things like that. I think it's a little bit exaggerated, but if you want to start at some point, maybe start with this one. You can check on the internet. There are a lot of these different strategies to understand these values or to fit the right values. Of course, again, it depends on the project. I think 30 methods inside a class, it's too many, but sometimes you have small methods, things like that. It can happen, but the idea is not more than 30. Okay, but I like more 20 probably. It's readable by human. 30, you just start to do a lot of scroll to find your methods, unless you have a good idea that can find, but it's a lot to think on our mind. I think that's just my opinion on this. So some tools that you can use to collect the lines of code. You can collect other metrics, but I focus more here on lines of code. There's these ones, the clock, okay, SonarQube, and I have here a comment for cross-project enterprise reporting. SonarQube is often the most complete solution because it has a lot of metrics and issues. You can manage issues, things like that. And they have a free version that you can use. Maybe in the cloud, if your project is small. For bigger projects, of course, you have to pay. But if you don't pass, I think 100,000 lines, it's still cheap to use it. After that, I don't know. So you have this, the clock, okay, sorcery, understand, CodeMeR, PMD, I already used in the past, something you can use in Java. ASLint is highly popular. And for Python, you have, for example, Shadon and sorcery. Just check these tools if you can really find on the internet. And all of them, they support at least lines of code, of course, there. They support other metrics also. So why should developers care about this? Benefits, productivity measurement. You can track progress. I think you understand this by now. Defect prediction, foresee issues in complex databases. We saw even formulas about this. Code quality, keep track of maintainability with proper line of code limits, because if you count lines of code, you can create a kind of alert system that counts. You can put a tool that every time there is a commit or something counts the numbers of lines. You say, okay, your file is becoming too big. It's not that you block, but maybe you can block and ask for a quick review, or maybe you don't block, but at least you receive an alert and talk with someone. Why don't you refactor your code? You can apply this kind of rules to control the dimensions of the objects that you have, packages, classes, and things like that, even projects. Practical impact helps estimate deadlines, guides refactoring decisions, and we saw a formula about that, and provides clear insights into project scope and risk. So why should architects and managers care? Not only developers, for project planning and I saw a lot of project managers using the lines of code or other type of similar metrics to try to guess how much time it takes to develop the project, so they can sell and understand what should be the price. Risk management, again, use line of code trends to identify technical debt. It's a risk associated always with the project because it's something that we have to pay later. And when I say pay, is really paying because someone will take time, and we saw a formula about that, that you should spend time to fix it, and that person is paid, right? And prioritize reviews for fast growing or large files, so you can detect files that are becoming larger and maybe, okay, I have to review this code or maybe refactor it. And of course, resource allocation, balance effort across teams based on the line of code churn in this case. So thank you. This is what I want to show you about this metric. And I drop here this sentence, lines of code metric is more than just a number. It is, and I hope you understand it. Now it reveals insights into project health, development, and potential issues. And I hope you understood that by the presentation that I did now about the lines of code. So this is my first video about metrics here. I study a lot metrics, as you may guess, during my profession. I hope you like this video. I will provide other metrics. I start with the simple ones, then I'll start to grow to something more complex. Like I can give you some examples. There are metrics that measure the coupling between classes, coupling in architecture between microservices, things like that. That can be useful for you to understand if I can change this code or not, what is the risk for me to touch this code. If I refactor this code and I have high coupling, maybe it's not a good idea. It will have a lot of implications to other classes. There are great metrics that we can export. There are simple ones, intuitive, like coverage and things like that, that they are easy to understand, but I just want to create you on the right mindset to be more scientific in your profession. So again, thank you for watching, and I hope to see you in my next video.